Hi everyone, welcome back to Art of the Part. In this video, we're going to talk about insert part modeling from a more basic approach, and then I'll have a follow-up video talking about more advanced principles, like edit components within assemblies. My hope is that this video can serve as like an introduction with these basic principles that will help you understand the advanced principles in the next video. And before we get started here, I do want to at least make mention or preach in this instance about file organization. I come from a background of PDM, which is product data management, and we set up file structure hierarchies for literally everything in such a way that if I have bolts, I have a file folder for bolts. If I have raw material, I have a file folder for raw material. And this is very good because if you ever get into a situation of PDM or product data management, you actually cannot have duplicates of file types. So if you have a M8 bolt and you name it M8 bolt, you can't have two M8 bolts in two separate folders, which is good and bad because if you put all this information in, for instance, our Ye Ole Pop Topper file folder, you're going to have to pull from that Ye Ole Pop Topper file folder for every instance that you have to use that M8 bolt. So make sure that you start getting in a good practice of organizing your files. And I can show you here an example with my work holding here. This is my master flash drive. I have a 5-axis vise and riser file folder, clamped risers, parallels, soft draws, soft risers. So in the instance of the soft draws, I can go in here. I have a soft draw style A and a soft draw style B. And then I have my parent file, which is the soft draw style A. And that is the reference or the parent insert file for all these other children, which are going to be my front and my back, which is what we're going to do here in this video today. So that being said, there's going to be some difficulties probably if you're downloading these files from the Google Drive, to put it lightly, but in essence, you're just going to go week by week and download it. I would encourage you to at least just set up a file folder for, let's say, Ye Ole Pop Topper. And I know I was kind of talking against this, but at least from an educational standpoint, you can start getting in a good habit of setting up your files in this way. Just put a 5-axis vise and riser file folder for the Ye Ole Pop Topper, soft draw blanks, and then the soft draw itself. This file folder for the 5-axis vise and riser, you're going to have to download it. It's going to be a zip file. You'll extract the files and just put them all in there. Soft draw blanks, you can also download these. There's drawings that are going to be associated to it. But this is going to be your blank soft draw, your master file that you're going to be using for your front and your back assembly here. And then soft draws will make a file folder for the soft draw style A-1, which is going to be the first part coming out of this soft draw style. You could also include your Ye Ole Pop Topper here. This can also be considered like a parent file. And then you can have file folders for your different FEA studies. So you could have like a 6061, you could have your 356, and then your acrylic as well. But that said, as long as you get all these files downloaded and you kind of organize it in such a way where you understand it, I think that's going to be helpful. So here in the background, I have the blueprint for the blank soft draw style A. Obviously, you'll be able to download this. If you can't find that download, here's the blueprint, and you can draw it as such. But what we're going to do is we're going to use this file as like the parent file when we're inserting it into the front and the back soft draws. So let's go ahead and start this lesson off by starting up a session of SolidWorks. And what I'm going to do is I'm actually going to open up one of my blanks for the soft draw style A. So we'll go to File, Open, and then locate that blank soft draw style A. So we'll click on that and we'll hit Open. So this is the parent file. Kind of showed you a little bit of the theory and the background explanation in the last video. And again, this is going to be from a more basic perspective. So we're going to kind of do everything from the part level, and then in the advanced video, we'll do everything in the assembly level. So what we're going to do first here is save these out accordingly as, or actually, sorry, we're going to set up new part files for the front and the back, and we'll save those files out. So as long as we have the parent file open in the background, I can pull from it as my insert part component. So let's go ahead and say File, New, and we'll start a new part. So inside this new part, I'm not going to go ahead and try drawing this all out one by one because I want all this common or shared geometry coming from the parent file. So instead, I'm going to go up here to Insert, and I'm going to choose Part. So I'll do Insert Part, and we're going to select that blank soft draw style A. And then we're going to hit the green check mark because I don't want to drop this out in 3D space somewhere and like unlink my origins. I want the origins to be in the same place as the parent file. So I'll go ahead and select the green check mark. It's just saying that the template used for making the derived part has different units from the measurement than that of the base part. All that is saying is that if I have units in this file, I just want those units to update accordingly from the file that's being referenced. So we'll hit yes. We can locate this if you're in a more advanced setting and you want to like offset this from the insert plane origin. You're more than welcome to. If I need to rotate it, that's fine. I'm just going to hit the green check mark because I don't need to locate my part any further. And then I have these planes here. I can either choose to select them and hide them one by one, or I can open up the insert part here, and then I can find my planes folder, and then I can select all of these, and I can choose to hide, or I can choose to show. All right. If I ever wanted to include more or less features or geometry, I could go and right click on this insert component, and then I can choose edit, or sorry, I can choose edit feature. And I can choose to either import only the solids or the planes or the sketches or whatever you want. There's a lot of flexibility in pulling in the geometry that you need. As default, I'm totally fine with this, especially with this lesson. Hit the green check mark. Okay, so what I'm going to do here is I'm going to do a file save as in two different directions. I'm going to make a file save as for the front, and I'm going to make a file save as for the back. So let's go ahead and do file, save as, and then we'll create a new folder for soft jaws. And then I'll just title this file folder soft jaws A-1. So softjaw A-1, it's the style blank A, and then this is the first part that's coming out of that style blank. And then inside that file folder, I'll go ahead and title this softjaw A-1, and then this is going to be the front, so it'll be F, and I'll hit save. And then I'll do another file save as, do file save as, and we're just going to change that last letter from F to B, which is going to be back. So now I've created two like dummy files essentially before I put any geometry into it for a front and a back. And what I'm going to do now is I'm going to start applying the geometry that is linked to the other drawing that I included with the assembly. So here's the assembly setup sheet. You can see all the different components in the bill of material. All these numbers are correlated to the parts that we're going to have to include with our assembly at the end of this. But we're focusing here on the 6th and the 5th, which is going to be the soft jaw style A, 1, B, and then soft jaw style A, 1, F. And this is actually going to be a two-parter because we have here in the title block, sheet 1 of 2. And then if you scroll down, there's actually going to be sheet 2 of 2. And then this is the geometry that we have to apply to these soft jaws that we just made in SolidWorks. So I'm going to keep this open in the background here, and we'll kind of go back and forth and reference this. Again, this is the more simple approach. When we have the more advanced approach, we'll kind of pull this all into assembly first, and then we'll do edit components at the part level. But right now, we're just going to draw this geometry as is. And I'm going to go and start with the front jaw. So I'll probably have to open that because I ended with saving the back jaw. So yeah, I got the soft jaw A-1-B. I'm just going to go to File, Open, and make sure I got the F open. So soft jaw A-1-F, open. It's going to look exactly the same. The only difference is that we're going to put the geometry of the soft jaw here on the front, and then we're going to put the geometry here on the back. So let's go ahead and get started drawing on this part. Make sure that this says soft jaw A-1 up here, and then we have an insert part with the blank listed as the first feature in the feature tree. So we'll click on this face here, and we're just going to start a sketch. And what we're going to do is we're just going to draw out some of this geometry here. I know that it's got to be centered from one side to the other. I got 0.563 from this side and this side. And then I got a couple steps going through this. So just like how I did with the Ye Ole Pop Topper, I'm going to just try to memorize the number of features here. And then I'll come back and I'll smart dimension it afterwards. So let's go ahead and just start here with the line tool. And then I'll make sure that I'm coincidence with this top edge here. And I'll come down, and I knew that I had to draw a flat and then a little step up like that. And then I had to come over, and then there was an angle, and then another flat, and then I had to make a little pocket there. And then I'm just going to close out this geometry because if I try to extrude cut this now, I don't see a watertight model. However, if I do close it out with that line there, you're going to see that it's all going to turn blue. Okay. Now we're going to go into Smart Dimension, and we're just going to Smart Dimension this from one side to the other. We're going to make this 0.5625. I'm going to use the fractional dimensions. You're more than welcome to round it off to 3 places. You should get something very similar. I'm going to do 0.5625 on both sides there. If I go back to my drawing, I have a value of 0.469. The fractional value of that is going to be 0.46875. And then if we look here as well, this should be collinear with itself. And then there's ordinate dimensioning system from this side telling me my values and where all these intersection points are going to be. I'll come back and I'll add the radii last because it'll make it easier for me to actually grab these intersection points from that 0 point here. Okay, so I have to actually apply a collinear value from this to this. So I can hold down the control key, I can grab this line and then grab this line. So both those lines are selected while holding down the control key, and I can choose collinear. All right, so those are in line, and then there's a value from here to here. I believe that is, yep, 0.0625. So I'll grab this line to that line, and I'll make that 0.0625. And then I will make another value for that top edge to the bottom edge here, which is 0.34375. And on your blueprint, you're going to see 0.344. Again, I just know the fractional values and where it's rounding to. You are more than welcome to treat this as 3 decimal places or the full fractional dimension. All right, so now we are at the stage where we can start dimensioning from this flat face here. So this is just like an ordinate dimensioning system. This is saying that this is 0. And then from this edge to this edge, it is 0.55, so 550 thousandths. So I'll go here to here, 0.55. This one is 1.08, and we'll just make it 1.0875. 1.0875. That degree I knew I saw before I went over was 45 degrees. And then the distances here were 2.0125 and then 2.203.125. Okay, so that's there. It's 2.0125, and this here was 2.203.125. And then the height on that, I forgot to grab it. Doesn't look like I left it on the print, but we'll just give a value. We'll make that 0.25. All right. And then we're going to go ahead and add some radii to this so we can continue on. So go ahead and take your fillet or sketch fillet tool. And if we look here on the blueprint, we do have values here that are typical. So we have a radius of 60 thousandths, so 0.0625, typical on all these corners. So we'll go ahead and we'll just grab all these corners. Oops, change our value here to 0.0625, and we'll just grab all these corners that we're applying that to be typical. We won't put it on these ones because when we assemble this soft jaw together, we actually want to have the ability to cut both of these pieces at the same time. And I don't want the radius here to interfere because it's going to be cut away anyways. So we'll just hit the green check mark. And then the value in which it's extruded down is going to be 0.34375. So we'll actually come in here, features, or sorry, I'm already in the, features, extrude cut, and then we're going to make that 0.34375. And then we just got to add another typical edge break here, which is going to be chamfer 1/64 at 45 degrees. And I think I showed this in the last video when we were talking about the Ye Ole Pop Topper, but if we don't know this value and it's calling out like 1/64, we can always just go into the sketch chamfer, or sorry, the chamfer feature, and I can say 1 divided by 64, and I can grab this edge. And that'll give me the value of 15,000. Green check mark. All right. And that should complete the front side of the soft jaw. So I'll go File, Save As, and just save it over or overwrite or just File Save. And then I'm going to go into the back jaw now, and I'm going to go here to the file that I open in the background. I can hold down the Control key and hit Tab and cycle through them. I can also just go to File, Open, and I can find the B, and I can open it, and it should open it if it's already open in the background. Okay, so we just drew the front geometry and it was all on this side. If we want the back geometry, we know that that back geometry has to be here. And this should be pretty easy. We'll just go ahead and, start a sketch on that face. And then just like what we did before, we'll just draw out a rectangle like this. And we'll dimension it to be center, 0.5625. 0.5625. And then there's a value here. It's 0.063 or 0.0625 from this edge to that edge. All right, 0.0623. All right, we might run into an issue here where I might need to extend this out because with the geometry that I'm going to place here with the sketch fillet might remove the geometry that's in place already. So I can go into the sketch fillet and make this 0.065 because that was the typical edge break. And if I try to grab that corner there, yeah, it says the fillet cannot be added because the value is like the exact same. So I might actually have to extend this out a little bit and just give a separate value. Make that horizontal. And then I can give this value here of 0.065, just like what I did before. And then I can give another value here. I can give it any value number, like an 1/8 inch there. And now when I try to put my 0.0625, even though that it's like intersecting directly, there's enough space for it to complete the feature. So that was the reason why I was unable to go ahead and apply that in the last step there. And then we'll extrude cut, and just like what we did before, it's going to be 0.34375, green check mark. And once again, we're just going to have to edge break this, and then that's going to be the value. It still remembers it. It's 1/64 or 0.01565, green check mark. Okay, and then we'll save this, file save as, whatever we want to do. Now we have our front and our back jaws drawn independently from each other in the background, but they're still pulling from the parent feature, which is very good. So if I ever had to make a change, I can make it on the parent and then it'll apply. So let's go ahead and pull this into the assembly of the 5-axis vise and riser. So if we go to File, Open, and we find wherever we downloaded that 5-axis vise and riser, that should have been a zip file on the Google Drive that you could access. And I'm going to open this, and I can just filter this out by assemblies. So right now I see part. If I go ahead and change this to type, I can find my 5-axis vise and riser assembly. It should be the top one. Click on that and hit Open. And just like how we did before with the FEA studies with the Ye Ole Pop Topper, I can create multiple configurations for different components to be active or suppressed. So you can see I have a hard jaw. If I go over here, this might open like that, but it's defaulting here in the configuration tab for me. I can cycle through the hard jaw with just the basic operation. There's also the hard jaw with the parallels. And then there's a hard jaw with the stop and the parallels. Let's go ahead and create another configuration for just the soft jaw. So let's go ahead, activate the hard jaw because that'll probably be easier. So that should be the first configuration. And then we'll add another one and we'll just name this soft jaw. And then hit the green check mark. And then we can go ahead and suppress some of these features like the hard jaws that are no longer needed. So I can click on this feature, and then there should be a little arrow that's pointing down, and then it has like a fully colored box and then a transparent box underneath it. So I can choose to suppress that, And that just gets rid of the feature in this configuration. And then I can click on this other hard draw and suppress it. So just make sure that you are inside of the new configuration that you made, which is soft draw, because I can still go back into here and access all these other components, but once I get into soft draw, those two components will be actually removed. I don't want to delete them out because these other soft draws will, or sorry, these other hard draw configurations might be helpful in the future. So as long as I'm in the soft draw configuration, I can go ahead and hop over here to the assembly tab. And then inside insert components, I can choose my front and my back. So I can choose my front, I can place it there, and then I can also insert my component on my back, and I can insert it there. And then I just have to line these up. These should share the same 8mm socket head cap screws, and I'm going to locate it in these front positions here. So just like what we've done in previous videos using assemblies, the way that we're going to connect these faces and these surfaces is by using the mate tool. Once again, it's located in the assembly tab. We're going to choose on the mate, which is going to be the paperclip. And then we'll select this through hole and we'll line it up with this hole right there. And then we'll do the same thing on the other side. And then I might have to pull this part up because it's like intersecting. So I can always just like click, hold, and drag without placing a mate. And then I can grab on this face and then mate it to that face. And then hit the green check mark. And then we can do the same thing on this other configuration, or sorry, this other component. And we'll grab on that through hole. We'll go there. That through hole, we'll go there. And then we can pull this part up. And then I can grab on that face. And then grab on this face right there. So you can see how I've replaced out my soft jaws now, or replaced out my hard jaws with the soft jaws. And the only thing that I have to add now is an additional mate for the offset or the gauge block that's going to go in between these when I machine or manufacture this. So if we open up the drawing here in the background, there should be a 30 thousandths gap in between them. And that's useful because we don't want the soft jaws to be pressing up against each other. We want the soft jaws to be clamping against the Ye Ole Pop Topper. So what we're going to do is we're going to add a distance mate. So we'll go to mate, and then we can choose this face to this face. And they're coincident right now, so they're face on face, but we're actually just going to add a distance here, and we're going to put in a distance of 0.03125. And that distance mate is located as long as these two faces are selected. There's an arrow, two arrows pointing in opposite directions with lines on either side of it. And then we'll hit the green check mark, and then hit the green check mark once again. And that should put it in the proper place. So let's go ahead and insert our Ye Ole Pop Topper. We could also bypass that distance mate by just pulling in the pop topper and then adding the mates accordingly. But let's see how it looks right now. So I'll go browse because I don't have the file open. I'll have to go to my Ye Ole Pop Topper folder, find my Ye Ole Pop Topper, go ahead and choose open, and I'll just drop it out here in 3D space. We can choose mate, and I can do this flat face to this flat face. It should realign it and reorientate it. We can also grab this flat on the bottom to this flat here. It should line it up. And then lastly, I'll grab this edge and I'll move it all the way over there. So that should put in place our pop topper. I would have to adjust this dimension here just so that there's a flat to flat. It seems I dimension that. It still needs to go another 30 thousandths. So let's go ahead and open this part. You can open that, change that dimension. I had 250. That should actually be 0.28125. My apologies on that, but it should be a quick fix. And I can hold down the control key, tab back over. Assemblies have updated. We can hit the green check mark, and now that is lining up flat to flat. So go ahead and save that assembly now, and we can go ahead and make drawings from this and actually import the entire assembly into Mastercam to start programming not only the work holding itself, but the second on and first operation from the Ye Ole Pop Topper. So in the next video, we'll talk about a more advanced approach by doing all this design process built from the Ye Ole Pop Topper inside the assembly rather than independently in the part files. So I'll see you in the next one.